Okay, so this entire chapter is on quadrilaterals and other polygons. So, first things first, what is a quadrilateral?
Yeah.
Does it have four sides?
Quadrilateral is a four-sided shape. Okay, so we know a couple of names for four-sided shapes, like a square, a rectangle. Right, so you have different kinds of four-sided shapes.
Rhombus.
Yes. But we're going to talk about all those different kinds, and then we're also going to look at polygons. So polygons could be any number-sided shape. Like a triangle is a polygon. A quadrilateral is another polygon, but so are these other shapes you see here. We've got a pentagon, what are the names for these? Five-sided figure is a pentagon. Six-sided figure is a
Septicon.
hexagon. Seven-sided figure, heptagon, absolutely. An eight-sided figure, octagon. Right? So the first thing we want to do is we know how many degrees are in a triangle. How many degrees are in a triangle?
180.
180. There's 180 degrees in a triangle. Okay, but now how many degrees are there in a quadrilateral? Or a pentagon? Or a hexagon? And so on. Okay, so the way we learn it is think about a quadrilateral. In a quadrilateral, I can divide that into two triangles. How many degrees are in the first triangle? 180. How many degrees are in the second triangle? 180. So how many degrees are in the entire quadrilateral? 360 degrees in a quadrilateral. Okay, then we look at the next one. This one used to be a five-sided figure, and the five-sided figure has three triangles in it. So it would be 540 degrees total. Look at the six-sided figure. How many triangles were inside of it? Four. Yeah. In the seven-sided figure, there were how many triangles? 5. Alright, so let me ask you a question. In a 10-sided figure, how many triangles would there be?
5.
Okay, both, so I've heard 5 and I've heard 8. Defend your answers. Why do you think 5? Why do you think 8? You don't think it's 5? Change your mind? Why do you think it's 8?
Oh, because, like, the first one it says 4, and then next to,
Yeah. A four-sided figure made two triangles.
that's how it goes in the other ones too.
So a five-sided figure made three triangles. Six-sided figure made four triangles. Seven-sided figure made 5 triangles. So you just take how many sides there are and subtract 2 to find how many triangles it makes. Think about a three-sided figure. How many triangles does it make? You take how many sides there are and subtract 2 from it. And that tells you how many triangles will be formed. So that's the formula. So for whatever number-sided figure it is, we can take the number of sides, subtract 2, and that's how many triangles we get. And we know every triangle has 180 degrees in it. So the interior angle sum of a polygon, right here's the formula. So the degrees in a polygon is equal to the number of sides minus 2, right, because that's how many triangles will be formed. And then we multiply this by 180. So the number of sides minus 2 times 180 gives us the interior angle measure of a polygon. Okay, so right here's the ones they want you to try. So it says how many triangles are formed when you draw the diagonals from a vertex in an octagon. So we talked about it. An octagon has how many sides? Octagon means 8, right? 8-sided. So how many triangles can be formed from an 8-sided figure? 6. 2 less than that number of sides. So there would be 6 triangles formed. And so what would be the interior angle sum? We would use the formula, which would be 8 sides minus 2, which means there are 6 triangles. And those 6 triangles each have 180 degrees. So you have to do 6 times 180. So you're going to need your calculator. Unless y'all can do that on paper or in your heads. I think we probably need a calculator. 1,080. Yes, that is correct. Any questions on how to do that problem? How many degrees are in this sign? Yeah. 540. How'd you get that? 3 times 180, right? This is 5-sided. So 5 minus 2 is 3. 3 times 180, which is 540. Okay, so here's a problem. We're going to have a little bit more details. It says Jen is building a corner cabinet to fit in a rectangular room. If she builds it with the angle shown, how can she determine whether the cabinet will fit? Okay, so let's look at the top of this shape. How many sides does that have? It does have 5, right? We have 1, 2, 3, and there's 4 and 5. So it's a pentagon. So I need to know how many angles are supposed to be in a pentagon.
3. No, it's supposed to be a pentagon, no, 5.
It's 5 sides. So to find the number of degrees I'm supposed to have, I would do 5 minus 2 times 180.
And you get 540 again.
It is 540. And we just looked at a pentagon. So when I add all of the angles up, I should get 540. So if she's wanting it to fit in a rectangular room, and she wants to put it in the corner, right? So what's the corner of a rectangle?
90 degrees.
90 degrees. So she needs this angle to be 90, right? To make it fit. So let's see if it works out. So I don't know what this is. Let's say it's X. So if I add those 5 together, I have to get 540. So I could say X plus 90 plus 90 plus 135 plus 135 has to equal 540. So I'm about to check all this math. 90 plus 90 plus 135 plus 135. Is it 450?
Yes.
Okay, and now if I want to solve for X, I need to subtract, that's one of the ugliest numbers I've ever done in my life. I need to subtract 450 from both sides. That tells me x is equal to 90 degrees.
Oh, yeah.
So my missing angle is 90 degrees. So will that fit in a corner of a rectangle?
Yes.
It does. So her cabinet is good to go because it has a 90-degree angle. So the first one you get 2,700.
I just thought you said.
Yep.
I heard 700. I thought I heard.
Okay, any questions here? Now, the next one, we haven't really looked at a problem like this yet, so I'm going to go over it now. So, they use the word regular. So we've talked about regular a little bit in the past. But what a regular polygon, a regular anything means, it means every angle has the same measure. So like a square. A square is actually a regular quadrilateral because it has all four sides the same, all four angles the same. So a square is a regular quadrilateral. Well, you can have a regular any shape. You can have a regular pentagon, a regular hexagon. What that means is all of the angles have the same measure, all of the sides have the same length. So we have a regular n-gon. We don't know how many sides it has, but we know all the angles add up, or no, that's a lie. We know that every angle has a measure of 172.8. We don't know how many angles there are, but we know every one is equal, and every one is 172.8. And so what we can do is we can use this formula that gives the interior angles of a regular n-gon is 180 minus n minus 2, 180 times n minus 2 divided by n. So what's really happening here? What's the top part of the formula telling me? What's that formula look like? 180 times n minus 2. What's that telling me?
It's gonna be whatever it is. We haven't done it in a while.
We did. No, we just did this. We just did that formula. What do we use this formula for?
The angles?
Interior.
It tells how many degrees are in the entire shape. Right? So like if n was 4, okay? 4 minus 2 is 2. 2 times 180, 360. So 4-sided has 360 degrees. Now if I want to take that 360 and divide it evenly among all the angles, how many angles are in a 4-sided figure? 4. So I'm going to divide by that n. I'm going to divide by 4. And so that 360 divided by 4 means I have 90 in every angle. If I plugged in a 5-sided pentagon, 5 minus 2 is 3. 3 times 180 is 540. And then if I want to divide that 540 equally, I would divide by 5 because there are 5 angles in the pentagon. So that's why I'm just dividing by n. I'm not dividing by n minus 2. I'm dividing by n. Because for every side, there's an angle that goes with it. So what we know then in this problem is they use this formula to get this answer. So at some point, they did 180 times n minus 2. They divided by n. And they found that in every angle, they should have 172.8. Okay, that's how you'd have to work this problem. Now, here's where you're going to have to do some algebra. This one's going to be tricky. So I'll give you a second. Copy it down and see if you can work through the problem with me. Okay, so we're going to put 172.8 over 1. Now I have a proportion. Fraction equal to a fraction. We cross multiply. So this tells me 172.8 times n equals, and then I have 180
times n minus 2 times 1, right? Which is useless. I don't need that. All right, any questions about what I've done so far? Now we need to get n by itself. What's the problem? There are n's on both sides. So, go ahead. I need to get the n's on the same side, but in order to get this n out, I'm going to have to distribute first. So 180 times n is 180n. 180 times negative 2 is minus 360. Equals 172.8n. So now I need to get the n's on the same side. So we can subtract 180n from both sides. If I do that, this cancels, and I'm left with a negative 360. Don't forget, the sign in front of the number stays with it. So I have to bring that negative down. And then what's 172.8 minus 180? It's going to give me negative 7.2 n. Now n is being multiplied by negative 7.2, so I divide by negative 7.2. And that tells me n equals, I mean I can't do that in my head, you'll have to do it in your calculator. Negative 360 divided by negative 7.2. So what did I just find? N. N represents the number of sides. So how many sides did this n-gon have? 50 sides. It's a 50-sided polygon. It's a lot.
I wonder what that look like, ceramic. Would it be a giant circle?
It's going to basically almost look like a circle. The deal is, the more sides you get, the closer to a circle it's going to look. And think about this angle measure. The closer this angle measure is to 180, the bigger the shape is. Right? Because if I had a triangle and I divided all three angles equally, I would have 60, 60, 60. Then for a quadrilateral I would have 90. Then for a pentagon it would be 108. Right? I know we hadn't done that. But it gets bigger and bigger, the angles do. Now the closer you get to 180, the closer to a straight line it is. Right? Because think about what's 180 degrees. It's a straight line. So 172 means I'm just barely moving over. That's why it looks almost like a circle. And it's never going to be greater than 180 because then it wouldn't be a polygon. Okay, so right here, this is the polygon exterior angle sum theorem. And here's what it says. If you were to make every line segment into a ray, like you see how these lines, we just continue them in a line. Then we have our interior angles. This time it's a pentagon. Right, I have these 5 green interior angles. But then I also have what's called an exterior angle. Interior means the angles are inside. So an exterior angle means we're looking at the outside. So the red angles are outside my shape. Here's what the exterior angle sum says. No matter what shape it is, no matter how many sides, when you add up all of the angles outside, you're going to get 360. Every time. So think about with a square. Okay, so all of these interior angles are 90. So it has to be 360. What's all these exterior angles? Well, they're all part of a linear pair. So that means this angle is 90. This outside angle, 90. This outside angle is 90. And this outside angle is 90. So it turns out here, for this one, we know that the inside angles of a pentagon are 108. We see how this forms a linear pair? So if the inside is 108, that means the outside is 72. And so all of these would be 72. And so I've got 5 72-degree angles. Well, 5 times 72 is 360. Okay? That all the angles on the outside had to be 360. Okay, so right here are the kind of problems that we can get. So this says, suppose that angle 1 is congruent to angle 3. Okay, so I need to write this down, make sure I'm following. So angle 1 and angle 3, they have to be the same measure. It says angle 1 is 3x, angle 2 is 2x. So this angle here is 2x. Okay, do we know what angle 3 is? Angle 1 is 3x.
So angle 3 would be 1.
No. They tell us what? They tell us angle 1 is congruent to angle 3. That means angle 1 and angle 3 have the same measure. Then they tell me angle 1 is 3x. So angle 3 is also 3x because they have to be congruent. So I have angle 3 is 3x, angle 1 is 3x, and they tell me angle 2 is 2x. So I drew that in. Now, do I know what the measure of angle 4 is? They don't tell it to me, but I can find it. Because 4 is an exterior angle. And it forms a linear pair with this angle. So if the inside angle is 90, and these two have to add to be 180, that means that 4 is also 90 degrees. Okay, what about angle 5?
90.
It's 90 degrees because I have another linear pair. And so angle 5 is 90. So the question is, what's the measure of all the exterior angles? Well, I know angle 5 is 90, angle 4 is 90. These three I don't know yet, but what do I know? These 5 are all exterior angles, and they have to add to be 360. All of the outside angles always add up to be 360. So I could say angle 1, which is 3x, plus angle 2, which is 2x, plus angle 3, which is 3x, plus angle 4, which is 90, plus angle 5, which is 90, has to add to be 360. Any questions where I got that from? Okay, so now we can solve for x. So what is 3x plus 3x plus 2x? 8x. 90 plus 90. 180. And now I can solve for x. So I could subtract 180. That tells me 8x equals 180. And then I could divide by 8. going to be a not very pretty number. 22.5. So that wasn't too bad. Okay, is the question, what is x? No. The question is, what is the measure of each exterior angle? Which means I'm going to take 22.5, plug it in for x, and find all of these exterior angles. Okay, so we know that angle 1 is equal to 3 times 22.5. Which when I multiply that out, that's going to give me 67.5. We see that angle 2 is 2 times x, which is 22.5. So that means angle 2 is 45. Angle 3 is 3 times 22.5. So it's 67.5. Angle 4 is 90. And angle 5 is 90. So I've now found the measure of each exterior angle. So these kind of problems are similar to their thinking. The deal is, though, what kind of angles do I have here? Are these interior or exterior? Are they inside the shape or outside? They're inside. So remember, the outside angles always add to be 360. But the inside angles, they change what they add to be, depending on how many sides there are. So since this is a pentagon, it has how many sides? 5 sides. So the first thing I need to do is figure out how many degrees are in a pentagon. How many degrees are in a 5-sided figure? So I would do 5 minus 2 times 180. Because that's my formula. N minus 2 times 180. That's going to give me 540. So what does this mean? If I add all 5 angles, they have to add to be 540. Well, since they've already established what the 5 angles are, we just have to write them down. So I have 3x plus 4 plus 7x minus 3 plus 6x plus 12 plus 6x minus 3 plus 90. Absolutely, that's kind of a trick. Right, you have to know that the right angle there is 90. And what do all these angles add up to be?
540.
540. And it's the same math, okay? Combine your like terms, and then get x by itself. So what do I have here? 3x plus 7x, that's 10x. 10x plus 6x is 16x. 16x plus 6x is 22x. And now then I have 4 minus 3, that's 1. 1 plus 12 is 13. 13 minus 3 is 10. 10 plus 90 is 100. Equals 540. And now solve. So I'm going to subtract 100.
440.
That tells me 22x is equal to 440. And then divide by 22.
110.
I don't think so. What'd you say? 110? 20. You had me thinking I did it wrong in my head. Okay. So x is 20. Is the question, what is x? No. The question is, what are all of these angles? So what am I going to have to do? Plug in 20 for all of the choices for x. So 3 times 20 is 60. 60 plus 4 is 64. 6 times 20 is 120. 120 minus 3 is 117. 7 times 20 is 140. 140 minus 3 is 137. 6 times 20 is 120. 120 plus 12 is 132. And then this angle, of course, is 90.
So we don't know what number angle they are, so we could put angle number one.
Right. Like on the last one, they were numbered for us. So like, if you were working the problem for me, if you wanted to, you could number them yourselves. 1, 2, 3, 4, 5. Right, but we don't have vertexes named. Like this is not pentagon A, B, C, D, E. So I can't name the triangle with 3 points. So I just went back in and labeled them. There's no just exact one way to do that. I just did the laziest way possible, just to be honest with you.